In this video, we will get an understanding of data validations, why they are important, examples of validations, and how to configure them within Boardwalk Velocity. Building validations in software development is crucial for several reasons, as they help ensure that the data being processed is accurate, consistent, and secure. Here are the key reasons why validations are necessary. Data integrity. Validations ensure that the data entered into the system conforms to the expected format, type, and range. This helps maintain the accuracy and reliability of the data stored and processed by the application. Security. Validations prevent malicious data from being entered into the system, which could otherwise lead to security vulnerabilities such as SQL injection, cross-site scripting, XSS, and other forms of attacks. User experience. By validating data at the point of entry, users receive immediate feedback on errors, which helps them correct mistakes promptly. This enhances the overall user experience by making the application more intuitive and user-friendly. Business logic enforcement. Validations help enforce business rules and constraints. For example, ensuring that a user cannot register with an already taken username or that an order cannot be placed with a negative quantity. Error reduction. Validating data early in the process helps catch errors before they propagate through the system, reducing the likelihood of more complex issues arising later. Compliance. Many industries have regulatory requirements that mandate certain validations to ensure compliance with standards and laws. For instance, validating the format of email addresses, phone numbers, and other personally identifiable information, or PII. Performance. Validations can help improve performance by ensuring that only valid data is processed and stored. This reduces the need for costly error handling and data cleaning operations later. Maintainability. Well-defined validations make the codebase more maintainable by clearly specifying the expected data formats and constraints. This makes it easier for other developers to understand and modify the code. Here are some examples of kinds of validations that can be performed. Type checks. Ensuring data is of the expected type, such as integers, strings, or dates. Range checks. Ensuring numerical data falls within a specified range, such as age being between 0 and 120. Presence checks. Ensuring required fields are not left empty. Formula errors. Ensuring formulas used do not result in errors, like division by 0, #NA, #ref, etc. Uniqueness checks. Ensuring data entered is unique where required, such as unique usernames or email addresses. Format checks. Ensuring data follows a specific format, such as email addresses, phone numbers, and postal codes. Understanding and handling these errors effectively can help improve the robustness and user-friendliness of your Excel models. Excel provides data validations, which can be leveraged to build validations. These validations are available under Data tab of Excel's ribbon in the Data Tools section. Click on Data Validation menu, and you can select the Data Validation option. Let's build a data validation for validating if the date entered is a valid date. A valid date could be between two dates, i.e., any date between today's date and a date that is 15 days ago. Once we have entered the parameters needed, click OK to continue. Let's test the validation. Let us enter a date in cell A2 that is outside the parameters and is still a date from the calendar. After entering the data, press Enter or Tab key, which triggers the validation on the cell. You will notice that the validation failed, i.e., the error was trapped, and an error message was displayed. Click on Cancel at this point. Alternately, a valid date could be just that it is a valid date. For example, February 29, 2023 is not a valid date. We will use the custom option of the validation criteria and put a formula there, equals isNumber, A2. Here we are leveraging Excel's way of storing dates internally as numbers. The formula returns true for a valid date and false for an invalid date. Click on OK to set the validation and to move forward to testing it. Now, let's enter the date February 29th, 2023 in cell A2 and click on the Return or Tab key to trigger the validation. Notice the error message. This is the default error message generated by Excel. This too can be tailored to our needs. Click on Cancel to continue. Let's go to the data validation and change the message that we would like to display. On the data validation pop-up, click on the Enter Text tab and enter words that we would like to appear on the title of the error box and then the message that we want to display. Click on OK to save the validation and to continue to test. Enter the date February 29th, 2023 in cell A2 and click on the Return or Tab key to trigger the validation. Notice the error message. It now displays the title and message that we chose. Now, let's add a drop-down list. We can use the data validation feature again for this purpose, and this time we will select Lists option of the validation criteria and put a list available in the workbook. Looking at the drop-down lists tab, we can use the values of the columns for drop-down lists. Let us use the values of the region column. Moving back to our Transactions tab and to the first cell in the region column, we see that there is a drop-down menu, and when we click on the selector, we find the values listed there. Now, if we were to move to the second cell, we don't find the drop-down list there. This is because we only configure the drop-down list for one cell. Also, the date validation was configured only for cell A2. To have the drop-down and date validation appear for all the rows, we need to save it in the row format so that when the row format is applied, the validations will be propagated to all the rows. Let's generate the row format for the transactions cuboid. We don't need to assign the format since it's already assigned. However, we need to go through the test format to apply it to our table. Now, when we click on cell M4, we see the drop-down list selector available. Therefore, whenever we configure the cell validations, we need to store it along with the cuboids format. For configuration, we use the first data row, which is then used to generate the format. In our setup, we used a list of fixed size, that is, it has 4 items, as the range being used suggests. So, now if we needed to add a 5th element, then we would have to modify the application. But this would be an inefficient way of configuring the application. We should find a way to make this dynamic in nature, or if we add a region, then this should automatically update the list being used. We can accomplish this by using velocities ranges for this purpose. Let's explore that possibility. The column region in the drop-down lists tab has a range name. However, this has an ID number in it. The ID can change from development to test to production server and would require the application to be changed, and this would again be cumbersome. Looking at the table name, we see it does not have an ID, but has the name of the cuboid in the range name, and this range name will remain the same when the application migrates from development to test to production. So, now we will use this to configure our drop-down list. Using Excel's function offset, with velocities table range names, we can configure dynamic column names and hence drop-down lists. The offset function in Excel returns a reference to a range that is a specified number of rows and columns from a starting cell or a range of cells. Let us explore how we can use this function. Offset has 5 parameters. The first is the reference, which is the starting point from which to base the offset. This can be a single cell or a range of cells. In our case, it will be the drop-down lists table name. The second parameter is the rows, which is the number of rows to move from the starting reference. Positive values move downward, and negative values move upward. If omitted, there is no movement at all. The third parameter is the columns, the number of columns to move from the starting reference. Positive values move to the right, and negative values move to the left. If omitted, there is no movement at all. The fourth parameter is the height, which is optional, indicates the number of rows to return in the reference. If omitted, the height of the returned range is the same as the height of the reference. And the fifth parameter is the width, This is optional and indicates the number of columns to return in the reference. If omitted, the width of the returned range is the same as the width of the reference. Let's close the bracket and press return. We now see a single column from the drop-down lists table. Let's define a range that holds this data. Let's copy the formula. Open the Name Manager from the Formulas menu. Click on New to open the Range Name Definition window. Paste the formula in the Refers to box. Change the name to DDL_regions. Click OK to continue. You can see the new range has been created. Close the Name Manager. You can quickly see the output of the DDL_range by entering the same in cell G2. You will notice that they have the exact same values. Let's clear the values from G2 and use them in the drop-down in the Transactions cuboid. Once done, we can test it by clicking on cell M2 to see the values being displayed. You will notice the column header region also shows up. We need to suppress this. Let's go back to the drop-down list tab and use the offset formula on the range named DDL range. In column H2, let's start with the offset formula. The reference in this case is going to be the DDL_range. We will shift the row by 1. Column we will not shift. The height needs to 1 less than the elements in the range. To determine that, we will use count A to count the non-empty elements of the DDL region's range and subtract 1 from it. Close brackets and press return. You will now see a list that does not have a header. Copy this formula as we will use it in the drop-down of the Transactions tab. Navigate to the Transactions tab. Edit the validation for cell M2 and paste the formula in the source section. Click on OK, and on testing the drop-down, you will notice the header is no longer visible in the list being displayed. We have a menu option for the cell, which is dynamic in nature. Now, if we navigate to the drop-down lists tab and delete the entry we had added, switch back to the Transactions tab and test the menu items for cell M2, we will find that last item is not visible anymore. The validations that we built were only for cells A2 and M2, however, they should be applicable to all the rows of the columns A and M. To do this, we will need to generate the row format and then test it to ensure that validations have been applied. Next, check cell M3 and M4 for the menu items. In this video, we covered why data validations are important, configuring validations using Excel's data validation features, how to use them in conjunction with velocities named ranges, and then how to apply them to the velocity table. In the next video, we will explore configuring business validation rules using velocity, which can be used along with the validations we just covered.